Today we are going to discuss reaction in solution. So today our topic is about the reaction in solution. So the term solution is the important term we are going to discuss. So how is important solution? Because in the chemical laboratory, most of the chemical reaction that occurred in solution form. So the term solution has the most important. So in a solution, we know that there is solute, solvent. So in a particular chemical reaction or particular solvent, we have to know the amount of substance present in a particular volume, or the amount of substance in a solvent, or how we know about the concentration of a particular solution. So there are three ways, or there are three terminology that are widely used to express the amount of substance present in a solvent or the concentration of a solution. So the first one is mass percentage. Mass percent. And the second one is molarity. And the third one is molality. And the fourth one is mole fraction. So what is this four terminology? These four terminologies introduced to express the amount of substance present in a particular volume or concentration of a solution. Out of these four terminology, right now we are going to discuss mass percentage. So forget all the three, we are concentrating on mass percentage. So what is mass percentage? Mass percentage is, generally we can explain or define, mass percentage is a way to express the amount of substance or the concentration of the solvent or solute present in a particular volume. So mass percentage can be defined as mass percentage is equal to mass of solute, mass of solute divided by mass of solution into 100. This is percentage mass. Mass percentage is equal to mass of solute divided by mass of solution into 100. This is mass percentage. So if we have 2 gram of a substance A, okay, we have a 2 gram of substance A, and so 18 gram of solution. We have 18 gram of solution, so in which we are adding 2 gram of solvent. So here the mass of solution is equal to a particular compound mass is 2 gram and solution mass is 18 gram. So we have to calculate the mass percentage of a particular solute A. So as the definition or the equation, mass percentage is equal to mass of solute divided by mass of solution into 100. Here the mass of solute is equal to 2 gram and mass of solution is equal to 18 gram plus this 18 gram is solvent mass. I'm extremely sorry. This 18 gram is solvent mass and A is the solute. So the mass of the solution is equal to 18 gram plus 2 gram into 100. So 2 by 20 into 100. So it is equal to 10%. So in a particular solution, the percentage of a particular compound, particular solute A is 10%. So here we calculate or we determine the mass percentage of a particular compound. So as we conclude, here we have given a solvent A, that is 2 gram. Okay. Here we have given a solvent 2 gram and a solute 2 gram and a solvent 18 gram. We have to calculate the mass percentage of A, because so mass percentage is equal to, we know, mass of solute divided by mass of solution into 100. So here mass of solute is equal to 2 gram and mass of solution is equal to mass of solvent plus mass of a solute, that is 2 gram plus 18 gram. So we will get 20 gram, that is 18 plus 2, that is 20 gram into 100. So this is 10%. Okay, so in the mass percentage we can calculate mass percentage of a particular solute present in a solution. So the first terminology is clear. So the second terminology is molarity. Molarity is represented in capital letter M. What is molarity? Molarity is number of moles of solute. Molarity is represented as capital letter M. That is, molarity is equal to number of moles of solute divided by volume of solution in liter. Volume of solution in liter. There is a second terminology known as molarity and is expressed in capital letter M. What is molarity? So we can generally we can say that molarity is the way to express amount of substance present in a solvent or particular solution given liter, or amount of substance or the concentration of a solution to determine the concentration of a solution. The way to express the amount of substance present in a given volume or the concentration of a particular solution. This is a term. All clear? What is molarity? In generally, we can define molarity is the way to express the amount of substance present in a given volume or the concentration of a particular solution. That is second terminology to express the concentration of a solution. That is denoted in capital letter M. So what is M? It is the ratio of number of molecules of solution to the volume of solution in liter. So by using this we can determine the concentration of a particular solution. So number of moles of solution. If we have given 4 gram of sodium hydroxide. If we are given 4 gram of NaOH, okay, in 1 liter of water, So the question is, determine the molarity of this solution. The question is, what is M? So we are going with this equation. We know that the equation M is equal to number of moles of solution divided by volume of solution in liter. So here we know that number of moles of solute, we have given 4 gram of sodium hydroxide. So by using 4 gram, we can determine the number of moles of solute. So number of moles, we know that number of moles is equal to mass in gram by molecular mass. So here we can determine, we have to calculate the number of moles of solute. So we have given 4 gram of sodium hydroxide. By using this 4 gram, we can determine the number of moles of solute by using this equation. Number of moles is equal to mass in gram by molecular mass. So here the mass in gram is equal to 4 gram divided by molecular mass of sodium hydroxide is 4 by 40. So this 4 by 40 we can add it to this place. This 4 by 40 is clear, I think. So in this equation or in this problem, we have to determine the molarity of 4 gram sodium hydroxide that is added to 1 liter of water. So we have to determine the molarity. So as per the molarity equation, we know that molarity can be determined number of molecules of solution divided by volume of solution in liter. So I have to calculate first number of molecules of moles of solute. So by number of moles of solute can be determined by using this equation. Number of moles is equal to mass in gram by molecular mass. So here the given mass is 4 gram sodium hydroxide and the molecular mass of sodium hydroxide is equal to 40. So the ratio is 4 by 40. So here M is equal to 4 by 40 divided by volume of solution in liter. Here the given liter is 1 liter. So 4 by 40 is equal to 0.1 divided by 1 is equal to 0.1 molar. So here we have given 4 gram of sodium hydroxide in a 1 liter of water. We have to calculate the molarity of sodium hydroxide. By using this equation, molarity capital letter M is equal to number of moles of solute divided by volume of solution in liter. So we know that as per this equation, we have to calculate number of moles of solute. So by calculating the number of moles of solute, we know that number of moles of solute is equal to mass of solute divided by molecular mass of solute. Here we have given 4 gram of sodium hydroxide and the molecular mass. This term is, and this the volume of solution liter is equal to 1. So how this term is arrived is clear, I think. 4 is number of moles of solution is equal to, can calculate by number of mass of the given substance divided by molecular mass, 4 by 40, and volume of solution liters is 0.1 normal. So as this calculation or this equation, we know that if we have to ask by someone or our tutor, our teachers or the faculty ask to us to prepare in a laboratory, may ask to prepare 0.1 normal sodium hydroxide. How we prepare the 0.1 normal sodium hydroxide? So as we know the molarity term, we are familiar with the term molarity, so we can easy to prepare 0.1 normal sodium hydroxide. Is it clear? How we prepare the 0.1 normal sodium hydroxide? Is it clear that if we have to prepare 0.1 normal sodium hydroxide, we have to take 4 gram of sodium hydroxide that should be dissolved in 1 liter of water. So then we will get 0.1 normal sodium hydroxide. Or other thing, if some question is arised 4 gram of sodium hydroxide is given in 1 liter of solution. So determine the molarity of the solution. So as per this equation, we can calculate the molarity of a solution, or we can prepare in future we may somewhere we are some posted in laboratory or like that. If someone is asked or someone is advised or requested to prepare 0.1 normal sodium hydroxide, so right now it is clear how to prepare 0.1 normal sodium hydroxide. 0.1 normal sodium hydroxide can be prepared by taking 4 gram of sodium hydroxide in 1 liter of solution. 4 gram of sodium hydroxide put in 1 liter of water, we will get 0.1 normal sodium hydroxide. Is it clear? And the third way to express the concentration of a solution is the molality. Molality, and is denoted in small letter m. What is molality? In generally, we can say that molality is the way to express the amount of substance present in a particular volume or the given volume, or molality is the way to express the concentration of a solution. What is molality? Molality is equal to number of moles of solute. As the molality, the first term is number of moles of solute divided by mass of solvent. Mass of solvent. So the molality is the ratio of, as the molarity, the difference is this molality, M-O-L-A-L-I-T-Y. The other term, the second term we are discussing is in the past, molarity, M-O-L-A-R-I-T-Y. That is expressed in capital letter M. This is expressed in small letter m. So what is the difference? The molarity was the ratio of number of moles of solute divided by volume of solution liter. But in molality, what is molality? Number of moles of solute divided by mass of solvent in kilogram. Mass of solvent in kilogram. That is molality. So mostly we are using the term widely, the molarity, to determine the concentration of a solvent. So the fourth one we are going to discuss is mole fraction. The fourth one is mole fraction. What is mole fraction? Mole fraction X is equal to, okay, before discussing the mole fraction, I have to tell something. Sometimes we are preparing a solvent, so maybe one solute is there and the other option or other chances or other situations, or 1 or 2 or 3 solutes are added. So by mixing, also general example like benzene and carbon tetrachloride, like that. If we are mixing carbon tetrachloride and benzene, so we have to know about the number of moles of particular solvent. Or forget everything in a chemical reaction. We have to come, if we are going to prepare, a pinch of salt is taken, and on the other hand we have taken a pinch of salt. So this is a mixture of solution. In a mixture of solution, we have to determine the mole fraction of a particular solvent. Mole fraction of a particular solvent. Okay. So how we can calculate the mole fraction? Mole fraction is equal to Na. What is Na? Number of moles of A plus, if we have to calculate mole fraction of A, we have A and B. There is 2 solvent. We have 2 solvent A and B. So we have to calculate the mole fraction of A. If we have to calculate the mole fraction of A, we can calculate Na divided by Na plus Nb. That is number of moles of A divided by sum of the number of moles of all the solvent, that is sum of the, or we can simply say that number of moles of solution. In this equation we can simply say that number of moles of particular compound, that is A, divided by volume of solution A, number of moles of solution, that is Na by N plus Nb. Mole fraction is nothing, we can say mole fraction X is equal to number of moles of particular solvent, divided by number of moles of solution. This equation can be simplified as, if we have A and B solvents, these are solvent, we are adding this A plus B solvent to the solvent, solute into the solvent. So we have to calculate the mole fraction of A. Mole fraction of A means X. Mole fraction can be determined and can be denoted X. So XA is equal to number of moles of A divided by number of moles of solution, means number of moles of A plus number of moles of B. And on the same way, if we have to calculate the mole fraction of B, as this equation, particular solvent, here the particular solvent, number of moles of particular solvent, here the particular solvent is B. So XB is equal to NB divided by NB plus NA. So here the discussion is about, if we have one mole solute is present in a solution, we have to determine the mole fraction of a particular compound, particular solute. The term is particular solute. We have A and B solute. So here we have to calculate the mole fraction of A. So by determining the mole fraction of A, we know that number of moles of particular solvent, that is number of moles of A divided by number of moles of solvent. Here the solvent is number of moles of solution, number of moles of the solution. Here the solution is Na plus Nb. So the sum of Na and Nb. So the mole fraction of A can be determined Xa equal to Na by N plus Nb. As the same way, on the other hand, we can determine the mole fraction of B. Mole fraction of B can be determined by number of moles of particular solvent. Here particular solvent is B. So Nb divided by number of moles of solution. So here the solution is Nb plus Na. So sum of Nb and A. Now sum of moles of number of moles of A and B. So that is Na plus Nb. So we are discussing in the by concluding this topic. Firstly, we are discussing the solution, reaction in solution. Why we are using, why these terms are we are studied, why we are studying this lots of terminology? Because most of the reaction in a chemical laboratory are occurred in solution. So it is very important to know the amount of substance present in a particular or given volume, or the concentration of a particular solution. So the way to express the concentration of a solution, the four terminology we are studied. The first one is mass percentage, the second one is molarity, and the third one is molality, and the last one is mole fraction. What is the first we are studied? Mass percentage. What is mass percentage? Mass percentage is mass of a solute divided by mass of a solution into 100, that is mass percentage. By using mass percentage, we can calculate the mass percentage of a particular solvent in a solution. The second one is molarity. What is molarity? Molarity is volume of solution. It is a ratio of mass of solvent. molarity is equal to mass of solute divided by volume of solution in liter. If we are advised, we are demanded to prepare 0.1 normal sodium hydroxide, how we can prepare? By using that chemical equation. I already discussed it. By taking 4 gram of sodium hydroxide, by mixing add into dissolved in 1 liter of water, this is 0.1 normal sodium hydroxide. If we are advised or to calculate, if we are given 4 gram of sodium hydroxide and 1 liter of water, by mixing them, so we have to calculate what is the concentration of the solution. So it is clear, by using the molarity equation we can calculate the molarity of that particular solution. So the answer will be 0.1 normal sodium hydroxide. As the molarity, the other discussion is molality, then nothing but the difference is L. That is, molarity is expressed in the capital letter M, the molality is represented in small letter m. So the molality is mass of solute divided by mass of solvent in kilogram. So the widely we are using the molarity. And the third one is mole fraction. If we are given, if our solution is mixing by two solutes A and B, the given solutes A and B, we are given A and B. This A and B we are going to mix in water. So we have to calculate the mole fraction of this particular solute. So we can calculate this mole fraction of this particular solute by the number of moles of this particular solute divided by number of moles of all the solute. N, this is A, this is B. So we have to calculate number of mole fraction of this one. We can easily calculate the mole fraction of this one by using the equation of mole fraction. What is the equation of mole fraction? Equation of mole fraction is number of moles of particular component divided by volume of solution. That is, the number of moles of this solute divided by the sum of these two solute. Number of moles of the sum of two solute. So we have discussed these three items. I think it's all clear. Thank you.